those already. And the other major modulation type is called direct sequence. There are actually two others as well. There's one called time hopping, which doesn't seem to have any applications and nobody actually knows how it works, so I don't know how they come up with the system. And there's one called chirp, which is really used by the military, and it actually spits out little packets of information at unpredictable intervals. Not very useful for radio control, I think. Frequency hopping. The 2.4 gigahertz band divides into 79 discrete channels in the UK, each 1 megahertz wide. I think in the States it's actually 83, I think, something like that. There are some restrictions worldwide on these bands. For example, in France, I believe it's 40 channels and a lower output. But broadly speaking, in Europe, we can use all 79 channels. So the transmitter hops from channel to channel in a predetermined order. It might not use all 79 channels, it might. That's the code that's actually held in the transmitter. At a predetermined interval, well, the Futaba frequency hopper actually hops every 2 milliseconds. So it's actually changing channel 500 times a second, which is pretty impressive. Of course, that has to be known to the receiver as well. There's no way that a receiver can receive a frequency hopping signal unless it has the same code as the transmitter. When you actually buy your Futaba system and you bind your receiver to your transmitter, that's what it's doing. It's loading that code from the transmitter into the receiver so it can receive the signal. The most common application for frequency hopping is Bluetooth, and I saw some madman, was it 2 feet, with the thing stuck in his ear earlier on? Yeah, Mr. Bluetooth. The good news about frequency hopping is it has the maximum use of the effective RF power. So we're limited in this country to 100 milliwatts peak power. Frequency hopping is great from that point of view because it uses these very small channels and you get the full 100 milliwatts right across those channels. 500 a second, it means you're using maximum power at all times. Direct sequence. What a nightmare this is. It's taken me weeks to try and understand this. Okay, so for direct sequence, we have even wider channels. They're 22 megahertz wide. There's 3 non-overlapping channels, but of course they messed that up by introducing some overlapping channels as well. Nothing simple, is it? What they do with this is they actually have, only a scientist could come up with this name, a pseudo-random noise generator. Just incredible. Of course it's not random. If it was random, the receiver wouldn't be able to receive it. It generates an enormous amount of noise and it pumps it on top of the signal and spreads it right across this 22 megahertz band. The receiver actually recognises the signature of this noise signal because it's also loaded with the code, picks the whole thing up, says, there's my bit of noise, I'm having that, takes the noise away and it's left with the signal. Very clever, but my God, what a lot of work. The real advantage of it is, because of the width of the band, you can shift an enormous amount of data in terms of volume and speed. And that's why it's used for Wi-Fi, because you can move a lot of data. The effective RF power, however, is significantly lower. There's only that peak power, that 100 milliwatts, only appears in the centre of that 22 megahertz band. So it means that the average across the whole transmission is significantly lower, maybe only 20 to 30% of peak power. So it does have some disadvantages. So what are we going to use for radio control? When I actually started looking at this, I looked at the RC discussion forums, and you would find lots of people saying, yes, spectrum system. Yes, well of course that's direct sequence, isn't it? Because it's not frequency hopper. No, they're not right. At least one of the manufacturers in the States actually said on its website that spectrum was a direct sequence system. It doesn't do so anymore because it isn't. All the current 2.4 systems do not use direct sequence simply because of the lack of RF power. So much power is dissipated in the outer areas of the frequency, it just ain't worth the candle. So although people might argue that Spectrum or XPS are not frequency hopping systems insofar as they generally transmit on 1 or 2 of the channels, they are actually under the frequency hopping modulation area of the spectrum. Spectrum. USM bands that we talked about earlier on. There's three main bands. There are others as well that generally are linked to specific areas, but these are the three that are broadly speaking worldwide. 900 megahertz in the USA, can't use that in Europe. 900 megahertz is used for the 3G mobile phones. So in Europe we get 868, and it's actually got significantly less bandwidth than 900. So I think we'll have to wait and see as to actually how useful it becomes. 2.4 gigahertz worldwide, we've already spoken about. There are some restrictions. Japan has some very odd rules on 2.4, which is really odd, bearing in mind half the equipment's coming from there. France has restrictions. There's even talk, in fact, I saw recently about Austria actually refusing to allow 2.4 gig gear to be used for radio control planes. So there's all sorts of funnies going on. And the last one is 5.8 gigahertz. This is a very interesting band, this. It's been generally a military band for donkey's years and also ham radio bands. But what's happening in the States at the moment is because of the enormously expanded usage of the 2.4 gigahertz band, some of the local and even wide area network manufacturers in the States are switching to 5.8. And I think probably when chips become cheap enough to work on those frequencies, we'll probably see some radio control gear there as well. So what's available? 900 megahertz USA, that's 868 Europe. XPS and their Grabner badge engineered soulmates will be producing modules on these frequencies from autumn of this year. I was talking to Craig earlier on. The Grabner website has some, I don't know if it lost something in the translation from the German, but it actually claimed that 900 megahertz wave bands, because it's a lower frequency than 2.4, would actually penetrate carbon fibre fuselages, which is remarkable because on that basis, then obviously 35 meg will go through a carbon fibre fuselage with no problem at all. I think that's a bit optimistic. There's another interesting one actually on the 900-868 Plentraco, who are a Canadian company. They have some absolutely stunning ultra lightweight indoor gear. And would you believe you can currently buy in this country an 868 megahertz transmitter module for your Futaba transmitter for £35. Hey, how about that for a bargain? It is very limited range and only suitable for indoor. But the Plentraco stuff actually has, would you believe, a 4-channel receiver incorporating a brushless speed controller, and it weighs 1.1 grams. We've got to get into indoor.